So we have proven that the left hand side is a subset of the right hand side because we picked an arbitrary element on the left hand side and we showed that it must be an element of the right hand side. Now we have to prove the converse. We also have to prove that an arbitrary element drawn from the set on the right hand side must be an element of the set on the left hand side. So let's try to do that. Now we have to prove that the set on the right hand side is a subset of the set on the left hand side. So let's draw an arbitrary element from the set on the right hand side. The set on the right hand side is A union B intersection A union C. So if X belongs to the intersection of these two sets, X must belong to the first set and to the second set by the definition of the intersection operation. X must be a common element of both these sets. Now, one of the ways in which X could belong to both of these sets is by being an element of the set A, because if X is an element of A, then it explains why X is an element of A union B as well as A union C. So possibility 1 is that X is an element of A, because of which it belongs to both of these sets. The other possibility is that X does not belong to A. Now if X does not belong to A, how could X belong to both A union B and A union C? If X does not belong to A, it could belong to A union B only if X belongs to B, because if it doesn't belong to A, it must belong to B in order to be a part of the union. So if X does not belong to A, then X must belong to B, and if X does not belong to A, then to belong to A union C, it must belong to C as well. So we have these two possibilities. If X belongs to both of these sets, either X belongs to A or it does not belong to A. If it does not belong to A, it must belong to both B and C. So this means that either X belongs to A or it belongs to both B and C. So we can say that X belongs to A or it belongs to B and to C. In other words, it belongs to B intersection C. So if X belongs to A or X belongs to B intersection C, it must belong to A union B intersection C. It must belong to their union. So we have proven that the arbitrary element X that we drew from the set on the right hand side is also an element of the set on the left hand side. So the right hand side is a subset of the left hand side. So combining this with the result that the left hand side is a subset of the right hand side, we have proven that the two sets are actually equal.